In this video, I want to discuss Lab 22, dealing with the addition reactions of alkenes. It's best if you watch the Chapter 11 videos before doing this lab. Chapter 11 is dealing with hydrocarbons, so you'll hear about alkanes, alkenes, alkynes a little bit, and aromatic compounds. This lab is dealing with alkenes. Let me talk about those just a little bit, okay? So again, Lab 22. And an alkene, let me just show you the simplest alkene. So the main feature to know about an alkene, and you're looking at it here, these things have carbon-carbon double bonds. This lab is dealing a little bit with nomenclature and a little bit with their chemical reactivity. First off, let's do a quick summary of nomenclature. This is not going to be a full discussion. Again, you really need to watch Chapter 11 videos before doing this lab. But one thing we see in organic chemistry is that the number of carbons are designated by a base name. Okay, so if you have one carbon, meth is used, 2 carbons, eth, 3 carbons, prop, 2 carbons here, eth. And the way we name this is that we use the eth portion to indicate the 2 carbons, and then we use an ene ending to indicate that we have an alkene of 2 carbons. So this is ethene. 3 carbons with a double bond is going to be propene. These compounds can also form cyclic compounds, cyclic structures. And the reason why I'm jumping straight to it is because you see one of these in the laboratory. And I'm going to do cyclohexene. Really common solvent you see in organic chemistry. Let's just break it down just a tad. The hex means there's 6 carbons. The ene obviously means there's a double bond in there. The cyclo portion means that it's a ring structure of 6 carbons. What that's going to look like is this. There's going to be one double bond. It doesn't matter where you place it. And then the rest of the bonds are going to be hydrogens. And remember the thing about carbon. Carbon always needs 4 bonds around it. Only one of the bonds is going to be double. Everything else is going to be single bonds. And notice it has a formula C6H12. Now typically we don't write it out in what we call the expanded structural formula. Instead what we do is this more symbolic structure. It's just a hexagon with a double bond on one side. And again, it doesn't matter where I put that double bond. As long as there's one double bond, it's cyclohexene. And this is the molecule that you'll see in the lab. Let's talk about the reactions that you're going to see. And the thing that alkenes do really well are what's called addition reactions. So there's cyclohexene. And then another one we'll see in lab, this is cyclohexane. These are the 2 that we use in the demonstration. Now the first addition reaction that you're going to look at is the addition of molecular bromine to the sample. Molecular bromine is sort of a, depending on the concentration, basically an orange solution. As long as there's an orange coloration to the solution, then bromine is present. Bromine is very reactive, especially when it comes in contact with a double bond or any type of pi bond, such as a triple bond would also react with bromine. The 2 bromines add across the carbons with a double bond, and you get this product. You get this dibromide compound. Now, the bromine does not react quickly at all with alkane, such as this one. If you give it enough time, if you give it some light, it does react very slowly, but it's not this kind of reaction. So in the context of this reaction, there's no reaction. Now, the observation that you're going to see is that this reaction stays colorless and this reaction turns orange. The reason why it's colorless is because the bromine is reacting. So the colorless observation is a positive test. Meaning, again, a reaction has taken place, an addition reaction has taken place. Orange solution forms, that means bromine is present. It means no reaction has taken place. This is a classic kind of what we call a qualitative analysis reaction to identify whether there is an alkene in the sample or not. And this is actually going to be on test 2. The second reaction is not on test 2, and it's actually an oxidation reaction with something called potassium permanganate. Very common oxidizing reagent. We're not going to get into all the details here. We see oxidation reactions in chapter 12. Here, again, it's a qualitative analysis kind of reaction. Is there an alkene present or not? It's a kind of a yes-no kind of question. Same 2 molecules, cyclohexene, cyclohexane, mixing with, again, potassium permanganate. And what happens when potassium permanganate reacts with an alkene like this, what it does is it forms a compound with 2 alcohols attached to it. Now, the alcohol functional group in chapter 12 is when we'll start talking about that. Now, the observation isn't this necessarily. It's actually this guy, this manganese oxide. This is a brown precipitant. So if you see the brown precipitant, well, this is a positive test. Again, a positive test saying that if you see the brown precipitant, an alkene is the sample. Potassium permanganate does not react with an alkane that way. There's no reaction. We'd say this is a negative test for a double bond. And again, those are the 2 reactions you're going to see in this lab. Now, I'm going to demo the reaction. You're going to watch the video, record your observations, part B, part C. Actually, this is part C, and this is part B. Nomenclature was in part A. But when you watch the video, I'm not going to talk a lot. Most of your background information is right here. Okay, so let's watch the video now. It's short.